Greetings. Good day. How are you guys doing? I hope you guys are well. We are here for our second lesson with your teacher, physical science teacher, Mr. M.A.C. Candiado, Marshall A.C. Candiado. I hope you guys are doing well and you were able to go through the first lesson, and I hope you understood the concepts that we taught in that first lesson. So now we are moving on to the second lesson. The second lesson in this series, we're going to have several lessons. So now today we are going to look at the second lesson. But before we move on to the second lesson, do you guys still remember what we talked about in the first lesson? Do you guys still remember what we talked about in the first lesson? In the first lesson, we talked about periodic table, the periodic table of elements. The periodic table of elements. It's a good thing that I still have it with me, right? I still have it with me, and you guys, I'm sure you are still having a similar copy. We talked about the periodic table of elements. We talked about how it has rows, it has groups, it has periods, right? It has groups and it has periods, and we explained how those periods and the arrangement, basically, of the periodic table is in order of increasing atomic number, right? So in order of increasing atomic number. That's what we talked about in the previous lesson. Okay? I hope you guys were able to understand, and I hope you are still with me. Right. So now, in this lesson, what is our topic for today? Lesson number 2. Lesson number 2. What is our topic for today? Right, so our topic for today, right, as written on the board, we are going to be looking now at the structure of the atom. The structure of the atom. Do we know what the atom is? Right, I hope we know what the atom is. If we talked about elements, because remember the periodic table, grouping and arrangement of the known elements in the world, and then these elements, if you break them down, if you cut them down and you go down to the simplest building block of them, you will find that there is what we call an atom, right? So we want today to look at the structure of the atom. We want to look at the structure of the atom. So our objectives for this lesson, we should be able, by the end of this lesson, we should be able to define the term atom. We should be able to define the term atom. Define the term atom. We should also be able to identify the subatomic particles that are present, the subatomic particles that are present in the atom. Because now when we look into the atom, we will find that the atom has different parts, right? It has different sections, and it is what we call subatomic particles that are found inside of it. So by the end of this lesson, we'll be able to identify these subatomic particles. At the end of this lesson as well, we should also be able to state the charges, right, and the masses of these subatomic particles, right? So we're saying we're going to identify subatomic particles, right? We're going to identify subatomic particles, and at the same time, when we've identified them, we are going to be able to say, okay, so this subatomic particle has a charge. We'll talk about what a charge is. We'll also talk about the mass, charge, and mass, and also the location of the subatomic particle. Okay? Are you still with me? Remember, subatomic particles, charge, the mass, as well as the location of the subatomic particle. Right. So also, by the end of this lesson, you guys should be able, we should all be able to draw the generalized structure, There is something we just refer to as the generalized structure of the atom. Right. So if I was to say, just draw the structure of an atom of carbon, okay? Right. That would be a specific structure. But then with the generalized structure, it will give us an idea of how we can draw the structure of any element, right, that is there on the periodic table. But remember, like what I said in the previous lesson, we are only going to focus on the first 20 elements. We are going to focus only on the first 20 elements, right? So I need you guys to pause the video now please pause the video for just a couple of minutes, go through, just look at the objectives, try to see if you can just get a grip of what the objectives are saying. These are our objectives for today, right? I hope they're visible. Okay, so pause the video for 2 minutes and allow yourself just to go through the objectives of this lesson. Okay, welcome back. I hope you guys have looked at the objectives. So the first thing we'll talk about is to define the term atom. I'm sure you guys know the definition of the term atom. I hope you guys are also taking the time just to read up in advance. For every lesson that we come to. You guys should read up in advance. So what is the definition of the term atom? So an atom is the smallest indivisible part. It is the smallest indivisible part of an element. Right? The atom is the smallest indivisible part of an element. Okay, what do we mean when we say indivisible? When we now get to the atom, it's difficult for us to break it down and say it can be broken down into simpler particles. Right. So we should know that in relation to matter and to elements, all of matter is composed of elements. Right? Like we said, anything that we see, anything that we feel, that we touch, right? All of matter is composed of some type of elements, right? And some types of atoms. Okay. So the other thing that you guys will have to look at, we won't look at it in detail in this lesson, right? But I also want you guys to go and look at the history of the development of the atomic model. Okay. So you guys should go and you look back. There was the development of the atomic model, how you had people like James Rutherford. In the 1700s, 1600s, people had already started to realize that, I think all these substances that are surrounding us can actually be divided into much smaller particles, right? And as technology improves, right, as more powerful microscopes are made, right, you are now able to see smaller and smaller and smaller things, which means that even as you go further in your studies, you will find that these atoms, even though we are saying now they're indivisible, you actually find at a later stage that, okay, so you can break them down. Now you can find that there's a proton and there's a neutron. Maybe there are other things that are even inside of the protons and the neutrons. Right? You just need the device which will allow us to see much deeper, and that's coming. It's the stage that is following. Okay, so we are now able to define the term atom, smallest indivisible part of an element, which takes part, smallest indivisible part of an element, which takes part in chemical reactions. So I added another part there. I added the part where I said which takes part in chemical reactions, right? Because if you guys know about chemical reactions, so we're saying we have, let's say maybe a reaction between hydrogen and oxygen to form water, right? So we would have maybe, I'm just going to write you a simple reaction, right? So if we were to take hydrogen, the element hydrogen, you saw the element hydrogen is the element number 1, remember. And we said we will focus mostly on the first 20 elements. So if we take hydrogen, right, hydrogen, plus oxygen, they will produce, when we write word equations, the atom is supposed to be here to say it produces, right? I'll write the product under. Hydrogen plus oxygen gives us water. Hydrogen plus oxygen gives us water. So we would take the element hydrogen and the element oxygen and they would combine to form water. But when we take this element hydrogen, we take the atom of hydrogen, right? We take an individual atom of hydrogen. Remember the symbol of hydrogen is this one. We say H2 plus it's a chemical equation, don't worry about it. Remember, when we get to grade 9, we will start writing chemical equations, right? So it's something that we must get used to. This is science, this is physical science, it will mature into chemistry and physics. So in our subject, we use chemical symbols. Hydrogen plus oxygen reacts to produce H2O, right? So then we will have to talk about later balancing of equations. We will have to talk about balancing of equations, because now you will have to put a 2 here, right? I'm just going to write the balanced equation for you. Okay, I'm going to write the balanced equation for you so that you don't say letters with unbalanced equations, so we don't understand what they mean. But there will come a time for you grade 8s where I'll explain how we balance equations. But to write this equation properly, it must be like this, because there is a way of counting electrons. These ones are atoms. So if here we have 4 hydrogen atoms, here we have 4, here we have 2 oxygen atoms, here we also have 2. That is not the crux of our lesson, but it's just important for you to know this. Right, so we should now be able to also know that now that we know that what the definition of an atom is, I would like you guys then to know which subatomic particles are in this atom, right? Which subatomic particles are in this atom. At this point, you guys should pause the video. Please pause the video for 2 or 3 minutes and allow yourself just to look at the generalized structure so that you get to identify and see if you can understand which subatomic particles are present in the atom. So please pause the video. Okay, so now we are moving on to the subatomic particles of the atom. So the atom, we'll start off by drawing. I will draw a generalized structure. I will draw a generalized structure of the atom. Right. So the atom. Let's use the element. Let's use the element carbon. Or I'll just draw. Let's say this is the first circle that I will draw. It will represent the nucleus of the atom. The atom has a nucleus, right? In this nucleus, we find protons and neutrons. Then surrounding the nucleus, what do we have surrounding the nucleus? What do you guys think we have surrounding the nucleus? Yeah, we have electrons. We have electrons that orbit around, they move around the nucleus. Okay, so inside of the nucleus, we have what we call nucleons. And these nucleons are in the form of protons. Let me write the word here. We have inside the nucleus. So the nucleus, the center of the atom. In the nucleus you have protons. It will all come together. Just be patient, right? We have protons and we have neutrons. So we represent the protons. I'll represent them using a small p, right? And I'll put a plus in front of it to show its charge, something we'll talk about also, right? We also have neutrons. Right? Let's use a small letter n. Right? This is also a small letter p. Right? So n and the charge, we'll talk about the charge of a neutron also. Right? So this is the nucleus of the atom. Now this nucleus is then surrounded by what we call orbitals. This nucleus is surrounded by orbitals. And these orbitals, these, when you draw ball diagrams, you draw the center, you write the name or the symbol of the element, and then you draw circles, right? You draw circles around the nucleus. Those circles are what we call orbitals, right? Orbitals in which electrons orbit the nucleus. They move around the nucleus. So the first orbital or the first shell, they're also known as shells. First shell, second shell, third shell. So if we have in here 2 protons, right, and we have 2 neutrons, let's say 3 neutrons, and we have, let's say, 4 protons. I have now decided to draw a diagram that has 4 protons, right? So which means the number of protons is always equal to the number of electrons. So now we're going to have electrons surrounding this nucleus. The first shell can only be occupied by 2 electrons. The second shell can be occupied by a maximum of 8 electrons, but in this one we will only have 2 because we know that the number of electrons has to be equal to the number of protons, right? So we now have 1, 2, 3, 4 electrons, right? So this is basically, what is the charge? So on these electrons, right, we might write them, what is the charge of the electron? Right, we'll talk about the charge of the electron. Let me draw them like E, so that you don't get it. It's easier to remember when they have a little E, because E means electron. Let me remove the cross. When we draw the cross diagrams, we will talk about how sometimes you use dots and how sometimes you use crosses. But for this generalized structure, I will place a little E, right? E minus, right? You will see why I write E minus when we talk about the charges of the subatomic particles, right? So this would be our generalized structure. The protons, right, are in the nucleus. The neutrons are also in the nucleus. The protons are in the nucleus, the neutrons are in the nucleus, and together they are known as nucleons. They are known as nucleons because they stay inside the nucleus. It's the same with you guys. You guys are called Namibians. You are Namibians because you stay inside of Namibia and you were born in Namibia. I'll be called a Zimbabwean because I was born in Zimbabwe, but now I have, like an electron, I have left Zimbabwe and I have moved to a different place, but I remain a Zimbabwean. Okay, so this is our structure of the atom. This is our structure of the atom. As we explain it, we will be able to understand it more. Right. So when we look at, let's give an example of an element. Let's say maybe it's nitrogen. If we think of an element like nitrogen, or which other elements do you guys know from the periodic table? Okay, so you can be at this moment right now. You can also be looking at your periodic table just to see the elements that you know. Right? You can think of the element sulfur. Which other element can you guys think of? Maybe it could be magnesium. Right? Magnesium sounds like a nice element. It's a metal. Right? This one is a metal. These ones are non-metals. Right? So the atoms of these elements all have, right? The atoms of these elements, like if we were to take magnesium, the magnesium element is made of millions of magnesium atoms. Do you guys understand? The magnesium element, an element of magnesium, if you were to hold a magnesium ribbon, that magnesium ribbon is made of millions and millions of magnesium atoms, right? And all of these magnesium atoms, all of them have the same exact properties. They all have the properties of magnesium. If you look at yourself, right? If you look at yourself, I'm thinking maybe it's you, Devson, right? David Zuka, you're watching this video. If you look at yourself, Zuka, right? Or if it's you, Maria Nebonga, if you look at yourself, if we take any part of you, Maria, any part, right, it will just be Maria Nebonga, right? If you were to take a cell from your hand, it's still Maria Nebonga, right? If you take a cell from any part of your body, that's how DNA works, because all of your cells belong to you. That is the same thing. You won't expect to find a cell from Candido Marshall on Maria Nebonga. No, it doesn't work like that, right? So it's the same for these elements. Sulfur is made of millions of atoms, and all of those atoms are sulfur atoms, right? So we now know that we have this atom, and elements are made of millions of atoms, and all of these atoms have the same properties. All of these atoms are having the same properties. then now we would like to look at the position. Let me find my rubber, my duster, right? We would like to look at the structure. I have a table that I'm going to draw here, right? I have a table that I'm going to draw here. For you guys, you can try and effectively observe as I draw the diagram, right? As I draw the diagram, you then notice the positions of different subatomic particles, right? So observe, right? So we're going to have position. Right, so in this table, I'm going to write the name of the particle. I'm going to write the position where it is found in the nucleus. I'm also going to write the charge and the mass of the nucleus. Right, so we have protons. Right, proton. We have neutrons. We have electrons. These are our subatomic particles, right? So these ones, as we have said, are found in the nucleus. The electron, where is the electron found? The electron is found orbiting the nucleus, right? So we say it is found in the orbits, right? Or in the orbiting orbitals, or we can say atomic shells. Atomic shell, that's a double L, atomic shell, right? The charges as well, the charge for the proton is positive. The proton is positive, the electron is the opposite of the proton, so it is negative. The neutron, however, has no charge. Its charge is 0, right? Its charge is 0. Right? So I need you guys now, you guys should look for the mass. You guys should look for the mass of these different subatomic particles and complete this table. Right. So now, when we are talking about the atom, right? On the atom, we will find what we call. We will find two numbers. So let's give an example. I'll write a symbol for that element. Right? I hope you guys were able to understand this table, right? And you'll be able to complete the table. So if you asked, right, I'm just rehashing on it. If you asked to say the proton, you should be able to know what its position is. You should be able to know what its charge is, and you'll be able to know the mass of the particle. I'll give you one. Proton's mass is 1. This one. Find its relative atomic mass. Okay, so let's look at an element. One of the first 20 elements that we talked about was sodium, if you recall. Sodium is written like this. Sodium. Its symbol is Na. Then when you look at your periodic table, sodium, Na, if you look at your periodic table, you will find that it has the number 23 and there's the number 11, right? It has those two numbers written on it. The number 23 and the number 11. Right, let me wrap this off. Right. There is no problem with me wrapping off material. Say I haven't written. You just pause the video, you rewind the video, and you can get the table. What? Simple as that. Right. So let me wrap this off. Because I want to explain to you a concept about atomic mass, atomic number, and mass number. Atomic number and mass number. This will be the final concept that I'll explain. We have already drawn the structure of a generalized atom. So we have already gone through the objectives of our lesson. So this will just be an addition. Right. So the atomic number, right? We have something that is known as the atomic number and the mass number. Atomic number, mass number. Atomic number, mass number. The atomic number is sometimes also known as the proton number. So the atomic number is the number of protons. Is the number of protons. The atomic number is the number of protons in an atom. Number of protons in an atom. So if you look at this symbol of sodium, this is the number that represents the atomic number. Because if we look at sodium, the atomic number is also equivalent to the number of electrons. So if you just see this number, the number 11, this is the atomic number. Atomic. Right. So this is the atomic number, and the atomic number is also equal to the number of electrons. Equal to the number of electrons. Equal to the number of electrons. Then we also have what we call this one, the number on top. The number 23 is what we call the mass number, or the nucleon number. This number shows us the number of protons and neutrons that we have, the mass. When we combine the mass of the neutrons and the protons that we have in the nucleus of the atom. Remember, we have the atom. Inside of the atom, there are protons and there are neutrons, right? So when we add their masses, right? When we add their masses, remember from the previous table, you were able to look for the relative atomic masses of a proton and for a neutron. So when we add the masses of a proton and a neutron, then you will be able to find the mass number. So the mass number for sodium is 23, right? The mass number for sodium is 23, meaning that it has 11 protons, because we know the atomic number. So if it is 11 protons, but then it is a mass number of 23, so how many neutrons does it have? I will need you guys to do the calculation as well. I will need you guys to do the calculation, and I will need you guys to go over all the work that we have done in this lesson. Right, so we have covered our objectives. We are now able, I hope we are now able to define the 10th atom. And we are now able as well to identify the subatomic particles that are present in an atom. And we are also able to draw the generalized structure of an atom. And we are able to do so much more because we have covered so much more material in this lesson. Right, so in the next lesson, right, lesson number 3 for next week, I will tell you what we will be covering in that lesson. But for now, you guys, there's a revision exercise. I had promised you in the previous lesson that we are going to have a revision exercise that marks the end of this week. Okay, so you guys should write that exercise, and you guys will email me, right, the responses, or you will send them directly to my WhatsApp account, right? So you will send them there. Okay, so I will meet you guys in what will effectively be the 3rd lesson, but the 1st lesson for the 2nd week. Okay, so peace and love. It's your teacher, Marshall A.C. Candiado. Thank you.